So the next thing we'll be talking about is double identities. So double identities, we also have double identities for sine, and we have double identities for cos. Now, sine is the easy one, so let's start with that. So we have sine 2a. So whenever you have 2 over there, you can rewrite it in that way. You have 2 with your angle, it can be written like this. This is the only double identities that you have for sine, and for cos. So for cos, however, you have 3 choices you can get. Whenever you have a double identity for cos, it could either be cos squared a minus sine squared a, or 2 cos squared a minus 1, or 1 minus 2 sine squared a. Now, you might be wondering, which one do I choose for a particular question or a particular problem? I normally say, when in doubt, try as much as possible to choose this one. If you don't really know what to do, use this one. Now, if you have questions that involves cos in there, where the majority of the questions has cos in there, you are best served by using this. If you have majority of the question that has sine in there, or you notice that you actually need sine, right? You are missing sine, but you notice that you can work with sine, try as much as possible to use this. If you see that there is a mixture of sine and cos and you're not 100% sure which one to choose, definitely choose the first one that we have over here. That's exactly what I recommend whenever you use double identities. Okay. Now, one thing about double identities you also need to know is double identities could also be written in multiple ways. With double identities, you do not expect it to always look like this, which is cos 2a. It could look like cos 50, whereby it can be rewritten as cos 225. You can break it down into maybe something like this. It could look like this, whereby this can actually be rewritten as. So one thing that comes to mind whenever you have questions that involves double identity is that with double identities, it doesn't necessarily always have to look like this. However, whenever you notice there is an even number and there's a possibility of bringing out a 2, you can actually, like in the case of 50 and 4a, you can actually bring out a 2, then use your double identities like you've learned. Now, there are rare cases whereby they would not be even number, but you could also use double identity. So you have maybe a number like this. Now this can actually be rewritten as, because if you think about it, 2 times 33 over 2 also gives you 33, and the answer would be, yeah, another example. This can be written as, which would be, yeah. So this is exactly how it works if you notice that you have odd numbers, whereby you can rewrite it as a fraction. So this is exactly how double identities actually work. It only works for sine and cos. If you need it to work for tan, you have to convert it to sine over cos. That's it. So now we are asked to simplify sine 36 over sine 12 minus cos 36 over cos 12. Now, whenever you're simplifying trig, at the back of your mind, you should always think algebra. And one of the basics of algebra is that whenever you have fractions, you get your LCD. So if I have A over B minus C over D, I understand that the first thing I do is that I get LCD. In this case here, it is BD. Then I can write everything in a big fraction like that. Okay, so that's what comes to my mind whenever I see fractions in algebra. I need to replicate that in trig questions. So I see this, the first thing I do is that I have my LCD. The LCD for this would be sine 12 cos 12. So as you can see, your numerator would be sine 36 cos 12 minus sine 12 cos 36. Now, one thing I also notice automatically here again is that this is A and that is B, and this is B and that is A. And I also see I have sine cos, sine cos. So that's definitely a compound identity that we talked about. So this would be written as 36 and 12. And because it's negative here for sine, the sign doesn't change. You have a negative over there. And that is over. So therefore, simplifying this would give you. Now, looking at 24, I actually see that 24 is double 12. So it reminds me that I could actually use double identities to simplify this a little bit, which is this. Sine 212 would be and as you can see, we can also cross cancel again. Sine 12 can cancel sine 12 out. Cos 12 can cancel cos 12 out. So all we're just left with would be 2. And this is an example whereby we actually combined our double identities and our compound identities to answer question. And it was based on the backbone of LCD. So whenever you have fractions in trig, try as much as possible to think of LCD and combine your fractions. And that's exactly what we did.